Hello everybody, welcome to the second video in this series of tutorials on test automation utilizing the AWS SQS. And in the first part, we created the AWS account. We placed the credential into the credentials folder, which will be used by AWS when your scripts are running. And also, we created our first SQS, the queuing service, simple queuing service in AWS console. So in this tutorial, we will be pulling the web service that I prepared for you. I'll be explaining the business use case and also will be making HTTP requests to that server, and that will post messages to our SQS queue. Um, yeah, let's go ahead and get started. So the first thing you need to do, navigate to this repo in the GitHub, and you can clone it or just download. So what I'm gonna do, I'm just gonna select code and then copy this link, and then I will want it to put it in my desktop directory. So I'll open the terminal. Let me make it a little bit larger. Um, so I'll navigate to the desktop directory. I'll get cd disk desktop. And now I can execute git clone and then providing the URL we just copied. So that will start the cloning process, and it will also actually clone the repository. It's right here. It downloaded to my second screen, but I'm gonna pull it on this screen that I'm recording. Um, the next thing you will need to do, open your IntelliJ and open this project in IntelliJ. After clicking open, you will see this pop-up. So we'll go to the desktop and then to the directory, and we will open it. Select browse project. I promise I didn't put any malware in there. It's actually opening on my other screen, which is the main screen. So I'll have to pull all the items that initially being open to this screen. After opening this project, go to COM, AWS SQS, controllers, and then SQS service customer. And then you will see the QURL string here. This is the URL where our SQS resides and where we will be sending the messages. Um, what we need to do now, we need to go to our AWS console and logging the root user. And then just type SQS. Click on my queue, or the name that you give to your queue. And you can see here the URL. So just copy this URL, go back to the IntelliJ or the ID that you use, and place um, the URL in here. Now go to the terminal, and we'll need to install all our dependencies from the POM file using Maven. So navigate to the directory where your project resides. In my case, it's desktop and AWS SQS Test Automation, and we can see the POM file here. So what I'm gonna do now, I'm going to say mvn install. That will install all the packages and build the project for us. It's gonna take a little bit, so I'm just gonna pause this video and I'll see you when everything completed and you have a green build succeeded message in the end. So now when you get the build success, what we need to do here, all your packages are installed, your build is fine. We need to navigate to the location where the POM file resides, and we're actually right here. And what we need to do, we need to start our Spring Boot server. We can do that just by typing mvn spring dash boot, not bot, semicolon run, and just hit enter, and it's gonna start your Spring Boot server. I'm gonna pause it for now because it's gonna take maybe around a minute to start it. So I'll see you when the server is up and running. So we just started our server, and if you get application available state readiness change to accepting traffic, it means your server is up and running. The next thing we will do, we actually test the connection and that we have the messages in SQS. So I'll be using Postman, but you can use pretty much any tool that sends HTTP requests. Let me just get this out of the way. All right. So first of all, we'll try to create a customer. So this is the post endpoint, just the customer, and we need to provide the first name, last name, date of birth, and email for our customer to be created. So select post from here, type localhost semicolon 8080 / customer, and then just type this information inside. John Doe, date of birth, John Doe at nomail.com. And if you click send, it starts sending the request. It goes through the server, and then the server will place it into the SQS. So we see 201 created, and this is the account that was created. So if we now go, um, actually, you see, I'm gonna start talking about use case now. I'm gonna expand a little bit later, but you see, it started with John Doe all lowercase, and now it's John Doe uppercase. It's pretty um, extremely simplified version of what we're trying to achieve here. Pretty much, let's say you have a business requirement that the business wants when user creates an account, we want that to be capitalized. The first and last name we want to be capitalized. Again, this is the super simplified version, but it will do the trick for us to actually building something with SQS. Obviously, the real world scenarios will be way more complex. And now if we navigate back to our SQS, and this is our queue, so we click send and receive messages. And if we click poll for messages, we can see one message here. This is the message that we just sent. And this contains the information we just sent, including the ID. ID is dynamically generated, randomly generated. So let's try to copy this 49557. Go back to the Postman. Yeah, this is the ID that we received over here, and open a new tab in Postman and just type get. Select get from here, localhost 8080 / customer, and then what was the ID? 49557. 49557, and we send the message, and we get this information of the customer. So it pretty much sent the message. Our endpoint read the information from SQSQ and returned this data. And also the good practice is to delete all the messages from the SQSQ upon their read. So if we go here and we actually pull for messages, we should not see any messages in our SQS. Yep, this message is gone. This message was deleted. So you can keep it, but it's not advice. It's not a good practice. You want to be read one time and perform certain action that you want to perform and just delete it pretty much. So I just briefly touched the use cases. One of the use cases that we're gonna work with is creating customer and capitalizing their first and last name. Another use case will be actually, let's say, you have customer who've done some purchasing, right? You capture the email, but you don't know who that customer is. You just know the email, and your marketing team actually says, "Hey, we actually want that to be linked when customer creates an account, let's look at their database and actually link that information so the next time we retrieve it, we have it. So this is another endpoint that we're gonna use. It's post, it's localhost 8080 purchase, and then we provide all this data. So what that will do, it stores, ideally it will store in database, but for our purposes, it's gonna store just locally while we're running the script. As soon as you kill the server, that information will be gone. But for the purpose of this demo, that will do it. So let's send this message. You see the message was sent, and then um, we're gonna create a customer again, and you see the email matches. So what that should do, that should actually link that information for us. So the customer ID returns 26565. So now in the first case, you see there is no purchase history. So if we send now, I think that's the wrong ID, 26565. Now if we send a message, now the linkage happen and we have a happy marketing team because now it's not just some John Doe at nomail.com. They actually know the first and last name. Most likely it will be more information like phone number, address, and etc. etc. So we just pretty much started our server and I identified the use case. So the next video we're actually going to deep dive into coding and implement the interfaces, build the interfaces, implement those interfaces. We're going to use kind of onion architecture to our solution, and I will expand on that next video. I'll see you in the next video.